In this video tutorial, we will be solving another type of logarithmic equation. This time, the equation will lead to a quadratic equation. So, an example is this equation right here. We are to solve logarithm of x minus 2 to the base 5 plus the logarithm of x minus 5 to the base 5 is equal to the logarithm of 4x to the base 5. So, again, check the bases first. So, all the three logarithms have the same base, which is 5. And then, on the left side of the equation, we are adding two logarithms, while the right side has a single logarithm. So, like what we did in the previous logarithmic equations, we express the left side as a single logarithm. Since it's an addition of two logarithms with the same base, then we will have a product from the product law of logarithm equals to so now the left side is also a single logarithm. Now we simplify the left side. Seven x plus 10 is equal to the logarithm of 4x to the base 5. So from here, we can conclude that x squared minus 7x plus 10 is equal to 4x. And we recognize this as a quadratic equation. That's why we say this equation leads to a quadratic equation. So how do we solve this quadratic equation? It's to make one side equal to 0. Make one side 0. So let's simplify, making one side 0. And then solve for x. So I will use factorization to solve this quadratic equation. I have x minus 10 and x minus 1 as the factors, which gives me two values of x, 1 or 10. As always, we have to check if these values of x will make the logarithms in the original equation valid. So let's try the first value of x that we got, which is 1. So if we substitute 1 to this logarithm, will it make it valid or invalid? Invalid, because x minus 2 will be negative. Also for this logarithm of x minus 5 to the base 5, substituting 1 to this value of x will make this logarithm invalid. X minus 5 will be negative. How about 10? So 10 as the value of x will make all the three logarithms valid. Therefore, we reject the solution x equals to 1, making 10 as the only valid solution for this logarithmic equation.